Hi guys, I wanted to give you a quick proof of the work energy theorem in the case of a constant force. Now, not all forces in nature are constant, so you have to be forewarned that this proof is only limited to the forces that are actually constant. However, just take it on a little bit of faith that with some calculus, you can actually show that the work energy theorem is true for all forces. So what we're trying to show is that the work done on an object by forces is equal to the change in kinetic energy of the object. And so we're going to begin actually with our equation of motion. Let's consider an object that is subject to a net force, and as a result of that net force, it's going to travel a distance. Let's call that distance delta x right here. So if I analyze this purely from the point of view of Newton's laws, then I would say that F net is equal to mass times acceleration. And I could then compute the acceleration from that as F net divided by the mass. And then from there, I could say that the equation of motion, v squared equals VO squared plus 2a delta x, now tells me how quickly the object will be going at the end of that period of time. Well, this is actually very interesting because this quantity v squared here reminds me of the kinetic energy expression that we had. Kinetic energy is 1/2 mv squared. And it occurs to me that if I multiply both sides of this equation by 1/2 m, then I would have kinetic energy sitting right there. Let's go ahead and distribute our 1/2 m. And 1/2 times 2 is equal to 1. So I get m times a times delta x as the result. Well, this is really nice because 1/2 mv squared is the final kinetic energy of the object, and 1/2 mv0 squared is the initial kinetic energy of the object. And now we take a look at what we have. We have mass times acceleration, which is the same thing as the net force, times the displacement delta x. If I subtract kinetic energy k0 from both sides, then I get the change in the kinetic energy over here, and the net force times the delta x times the distance traveled is equal to the net work done on the object. And so we have net work is equal to change in kinetic energy. I hope this enlightens you. The key point is that the work energy theorem is logically identical to the equations of motion that we've used before. But as we've seen in class, it's easier to use.